We're going to continue our experience with factoring, and we're going to start working with factoring trinomials. Now, remember, a trinomial has three terms. There's going to be two clear cases for when we want to factor trinomials, and that's when the second degree term is a coefficient of 1 or when it's not equal to 1. So you're going to utilize that to look at which method to use. So let's first look at cases where the second one is 1. So when we have a coefficient of 1 in front of x squared, n squared, a squared, we want to find the factors of the number c. And we want to find all pairs of that. Once we know the factors of c, we look at it and we say, okay, what are the factors of c that add to equal b? And then if there's no such integer that meets that criteria, it's not factorable. It's a prime polynomial. If there is a set of numbers, then we're going to move into the factoring process. So let's look at this one. First, we're going to look at the number 20. So what are the factors of 20? Well, we've got 2 and 1, but 2 plus 1 is 21, so that doesn't equal 9. I have negative 20 and negative 1, but when I add those together, that's negative 21, so it's still not 9. 10 times 2 is 20, but they add to be 12, so that can't be right. If I do negatives, I get negative 12. And if I have all addition symbols, guys, that means that I'm using the same sign. So 5 times 4 is 20, and 5 plus 4 is 9. So then I know that that's the pair that I want to use there. Now that I know it's 5 and 9, I know that this factors to a plus 5 and a plus 4. So if you look at the factoring handout that I also attached to the announcements, it talks about how to know if it's plus or minus in the middle of the parentheses. I would just take a look at that with this video so that when I reference it, you have the ability to look at that sheet. Now I have b squared minus 7b plus 10. The last symbol being a positive behind 10 means that both of my factor terms are going to need to be negative, or they're going to both need to be positive. So because I have that negative 7b, they're probably going to have to be negative. So I'm going to look at the factors of 10 that add to be negative 7. Well, 10 and 1 doesn't work. Negative 10, negative 1 doesn't work. 5 and 2 works, but it gives me positive 7. So if I look at the negative, then I'm going to get negative 7, which then means that my parentheses are going to be x minus 5 and x minus 2, or in this case, b, because I'm using b. So if you have a negative factor, you use subtraction in the parentheses. If you have a positive factor, you use addition. Here I have t squared plus 3t minus 5. According to that factoring handout, when I have minus 5 as my last term, that means that I have two different signs for my factors. So one factor is going to need to be positive, and one factor is going to need to be negative, and that's going to impact how we do this problem. So if I want to look for two integers, the product of negative 5 and a sum of 3, that doesn't happen because the only possibilities to get 5 is 5 and 1. And 5 and 1 would add to be either negative 4 or positive 4. So this is going to be prime. Here, I want to find what multiplies to be 6q squared, but adds to be negative 5. So when I do that, I get step 2. And so it's going to factor to p minus 2q and p minus 3q. This one's a little bit tougher. You're not going to see as many of these in the lab. Here I have a minus sign behind that last term, which tells me I'm looking for two different factors. But because every single term has an a, I would factor out an a. And then because every single term is divisible by 3, I would factor that out because look at how much simpler that is. I just need the factors of negative 5. The factors of negative 5 would be 5 and 1. And if I have a negative 1 and a positive 5, that gives me 4. So negative 1 is minus 1. Positive 5 is plus 5. Now, when it's not equal to 1, it is a little bit more involved because we've got to think about more things that happen here. So what we do is we look at the number in the first term times the number in the second term. So 6 times 10 would be 60. So I'm looking for the factors of 60 that add to give me negative 19. So the integers would be negative 15 and negative 4. I know they're both negative because it's a plus sign by the 10. Again, look at your handout. So I'm going to actually have to do this as factor by grouping. So I'm going to take that negative 19 and I'm going to expand it out into the two factors that I saw before. We said negative 15 and negative 4 would give us the right value. So then I'm going to group them together. And in the first parenthesis, I can take out a 3k. And the second parenthesis, I can take out a 2. And then look at this. They have that in common, which comes to the front, 3k minus 2. Take a look at the factoring handout. This is also going to be really helpful when you see it happen with the dialogue there. Sometimes we need an alternate method for factoring. Sometimes we're looking at what can I fill in the blank with? Can I use trial and error? I don't want you guys using trial and error. I know the directions in the lab might say trial and error. I want you to do 10 times 3 is 30. What are the factors of 30 that could give me 17? So I don't want you to use this method, but if you did use that, you would be able to get to this answer going back the way that we did it with factor by grouping. I don't really think trial and error is appropriate. Same thing here. 6 times negative 5 is negative 30. What are the factors of negative 30 that give me 13? And this is what you should come up with. So I want you to work these two problems on your own using that method and not using this trial and error method. So these are the basic steps that we would look at. And this is in the factoring handout. You're going to take the coefficient of the x squared term, multiply it by the c term, and then you're going to look at what is the middle. I need it to be the middle. If that isn't possible, it's also going to be prime. So if we look at this, we can do some trial and error. And if we also think about what are the factors of negative 30 that add to give me 7, I would realize that 30 to give me 7 could be 3 and 10. So I would be able to look at 3 and 10. I could use a positive 10 and a negative 3. And then once I factored by grouping, that would give me this answer. So again, I don't want you using trial and error. That's going to take you down a very long road. I want you to write this as 6m squared minus 3mn plus 10mn minus 5n squared, and then factor that by grouping. That's definitely the appropriate method here. And this one, I really liked that we factored out the negative. If you have a negative leading term, so you're negative in your squared term, it's best to just take that negative out front from the beginning and then to use the methods of factoring. So we would do 2 times 12 is 24. What are the factors of 24 that add to give me 5? Then I would factor by grouping. Same thing here. I can factor out a 2m, so I'm going to do that because it makes my life simpler. Once I do that, I can do 2 times negative 3, which is negative 6. What are the factors of negative 6 that give me 1, which would be a positive 3 and a negative 2? Then I would expand it out and factor by grouping, and you should get this answer right here. And so that's the factor by grouping process. Again, I really don't think it's beneficial for you to use the trial and error. It's going to get you frustrated in the lab. So if we look at factor by substitution, that's going to be kind of an interesting thing. We can basically say, I don't want to look at that as z plus 5 squared. I want to look at it as x squared. I think this is not an efficient way of solving this, but the book wants me to show it to you. What I would look at it as, I have z plus 5 squared and z plus 5, so I'm just looking at 8 times negative 3, and what are those factors? But they want you to actually replace that with x squared, and then once you get to the very end, you replace x with z plus 5. That's fine if that's how you want to do it, but I just leave the z plus 5 squared because I'm looking at 8 at times negative 3 is negative 24. And what are the factors of negative 24? They give me negative 2. Well, it's negative 6, and it's going to be negative 6 and positive 4. So I'm going to factor by grouping and get that down there, but it just keeps you from having to look at that z minus 5 in an equation, which can be confusing. Here I have something to the 4th power, which means that that variable is going to be rewritten like this. So I could see it as this statement. So because it's to the fourth and this is squared and not linear, I can rewrite it in a way that it's linear, and then I can just factor it like normal. 6 times 5 is 30. What are the factors of 30 that give me -3? Well, that'd be -15 and +2. I would factor by grouping to get this answer, and then I would replace that x with the r squared just like I did here.